Hi guys. Hey, this is just a little addendum onto the last video there, the third video for Unit 2. Um, Gosh, I even need to know which one I'm talking about here. But I don't think the screen, yeah, so Unit 2, Activity 2, the screen shifted over and I was trying to explain and show you guys the expectations and how do you do this stuff on your calculator. So the last video kind of left off and these are the completed notes here, so you should already have a copy of these. But I was asking you for part D here. Is there a time after 2000 where the two towns once again have the same population? And a way to do that on your calculator is to set the functions in part B equal to one another. So in the last video, I just kept talking, but I guess it didn't switch over. So I have a way to make sure it's going to switch over this time. So I apologize. But if you were going to do that on a calculator, and let me write that down here as I spill my coffee all over the place. So go ahead on your calculator right now and plug in the gray function from part B. That's a 1600x plus 20,000. And I'll switch over to my calculator in a second. And then the blue function that says y equals 20,000 as an initial value, 1.07 to the x. Plug those in. I'm going to share my calculator with you. Hopefully this time it will switch over so that you guys can see this happen. So now that's what you should be looking at. Two functions in there. And let's go ahead. I always kind of like to just zoom in a standard viewing window. And like I said in the last video, even though it wasn't showing, I'm comfortable messing this thing up. In a standard viewing window, really, if I hit enter into that whole thing, let's see if I can annotate here for a second. This 10 by 10 window goes back 10 to 10 and up to 10 and down to negative 10. So you're not going to see anything. So, and that's important to know when you're making these guesses as far as how to get your graph to actually show up. There are also other features you can do, such as zoom standard, or it's not standard, but if you go down here and your calculator will do a best guess sometimes if we haven't talked about it already. So I just hit the zoom feature and went down to zoom fit. The zoom's here, went down, or you can rewind the video. And let's see, that's actually not a bad guess. So we'll just leave it at that. But even in the last video, if you wanted to choose your window, you know that your first initial value is here at 20,000. So the question that they're asking you that from before is they want to know if there's another crossing here, and there is. And we'll go ahead and find that right now live with you. And the easy way for you to do that, again, if you want to sneak a peek at my window, again, I just did the calculator guess the right one. Here's the specs on it: minus 10 to 10, scale is 1. Um, I can get rid of that if I need to. Y minimum of 4,000. And notice it goes up to 40,000, mainly because my Y intercept to start with was 20,000. So a lot of times, even if I had to plug in the values myself, I would make sure that my Y values are between 4,000 and 40, or it doesn't matter, 10,000 and 60, whatever values you choose. You just have to make sure that you'll be able to see at least something to get started on. And in this case, we don't have to do much more. So I just zoom fit. And if I go back to my graph, let's go ahead and do this now. So second, calculate. You should be getting good at this now. Intersection. Enter. And if I hit enter there, I'm going to get 20,000. Remember your calculator, depending on which one you're using. Um, Notice this will jump graphs too. That's what you just saw happen there. That's why the numbers are changing, or going from one function to the other. But I'm going to go over towards where I want the intersection and just hit first curve. The calculator is just saying what's the first line you want them to consider. It doesn't matter which one in this case. The second curve is obviously the other one, so just hit enter. And by curve, they mean function. It could be a straight line, parabola, exponential, whatever. The guess is just there for you to make an educated guess. I usually bypass that. Just hit enter one more time, and there's your intersection. And notice that's the same thing as the answer that was found at the end of the video there. at 4.8 years, and you can hear my daughter yelling in the background, the populations will then again be the same at 27,714. After that, I know I keep referencing that video, this graph here will go up faster, the red one, than the blue line forever. They won't hit again because exponential functions dominate in the long run. So don't forget this value, 4.8 years. That's the little addendum onto the video that should have been there before. I apologize to make you guys come back and watch this thing, but you'll notice our answers are still there. So 4 point right in here, 82 years, population will be 27,714. Now, something in particular to notice, you guys have been working by hand. I mentioned this, I think, again in the last video, but sometimes, most times, you've been working on by doing stuff um, by hand. Let me show you something real quick since I got you. If you were to do this function, again, first function was 1600 x plus 20,000 and set that equal to 20,000. This is why I said it might be on the midterm or the final. It'll be on one of them. You cannot do a linear function set equal to an exponential function because there's no way to isolate that x by itself. Even if you move stuff one way or the other, it doesn't matter. There's no way to get that x, or no factoring, no distributive thing, or multiplying fraction. It doesn't. There's just not a way on the planet known to do that. So if you ever, hint hint, get this on an exam, use your calculator like we just did. Okay, that's it for now. Use your calculator and take care.